Welcome back to another video. Today we're looking at the fx991 Casio Classwiz calculator. We're going to be looking at the problem that you see on the screen up the top there. It's one where we have three unknowns, so a linear equation problem with three variables. How do we solve that? So if you read the question, a group is given a presentation, there's three sections to deliver, and there's a few things that they have in terms of conditions. It's decided that the conclusion is more important than the introduction, and so that will be 1 minute longer. The professor advised that the justification section should be 1 minute longer than the length of intro and the conclusion section put together, and the task is to form and solve the system of linear equations. You solve it in order to find the ideal time given to each section. So before we talk about how we're going to solve this, we're going to think about what are our variables. What are the things that are changing? What are we measuring? What do we want our outcomes to be? Something to do with the amount of time for each of the section. So it's very important that we do this actually. We start by defining them. We say we let. So let it happen, let it be, you know, it's a strange thing, but it's just what it is. I, J, and C will be the number of minutes for each of the sections. And then we can get started. Why is this 669? I don't know, I was just pressing buttons so I could focus the camera. Okay, so moving to the first point, that the whole of this thing needs to add up to 15. We have an expression where I plus J, to make that a bit clearer, plus C equals 15. So that's the first equation. Our aim is to get all the variables on the left and a number on the right. The second phrasing that it tells us is, if I say it a different way, if we add 1 minute to the introduction, that's how long the conclusion must be. So the way to write that in terms of maths, we could say that conclusion is equal to whatever the introduction is plus 1. And we put all of the variables to one side, and we'll make sure that I is at the front, and maybe we'll keep that positive, so we'll move the C over and the 1 that way, and then what we'll end up basically is with I subtract C equals -1, and then that's our second one. Our third point, we could say it differently, like we could say lastly, if we add the introduction and the conclusion together, you know, I plus C, and then we add a further minute, 1 minute, then this should be the length of the justification section. That's according to the professor's instructions. So we'll have whatever the introduction plus the conclusion plus the extra 1 minute, that should equal the justification section. We're going to have to rearrange that so that we have the I, J, and C on the one side. So in order to keep it correct, move that J over and it comes the second one. I have this, and then the 1 is going to have to go over the other side. So that's our third equation now. So as we can see, we've basically got a system of linear equations here. We've got three, and that's really what you need to solve for something that has three unknowns. We need three equations. And if you write that clearly, we've got 1I Okay, so there are the simultaneous equations as such, which we might call systems of a system of linear equations. And writing it like this is very useful for later. The intention of this video is to talk about how to solve this on a calculator, and in the most basic way, we're going to do it using the solving equations function. So we go to menu by pressing this menu button. And then we go down to the equation function again, and here we're going to look at simultaneous equations. Now this, you know, maybe GCSE you'd only ever do 2, but here we clearly have 3 unknowns. So we're going to boldly put in 3. You'll notice we've got an X, Y, and a Z, and well, we've got I, J, and C, but it doesn't matter. If you just remember the order that it's in, and we'll keep to our order as well. So now I'm just going to input all of these values, bear with. And once we have all of those in, the only thing left to do now is to press equals to actually solve the thing. So we're going to get a values of x, which if we remember, x is the first variable, is I. So we've got I is equal to 3, cool. And we press equals again, and we get that the j here is equal to 8. Is that the same as on a Scrabble game? Maybe I don't know, I don't play it enough to know. And here we have that z is equal to 4, in our case c equals 4. So we've got this sort of solution here to these three equations. If you were to do it without a calculator, you would have to rearrange one of these, substitute it into another one, eliminate one of the letters, and then solve simultaneously with a set of two unknowns, put it back in, make sure it's consistent with the rest. It could take a long time. But the calculator, as you can see, does that fairly quickly. You press equals again, you're good to go for another one. What I'd like to explore actually is a better way of doing this, which is solving it using matrix operations. So with matrix operations, the form above that we see, each of the equations up here has the same order of variables, and the constant term is to the right of the equal sign. Okay, so that's the form that we have it in. And if we do have it in that form, then we can write it also in matrix form. So now I've written it in matrix form. It might require a little bit of background in matrices to understand how this works, but I think you could probably get used to this standard format of seeing things just by using a bit of your wits and thinking, okay, the coefficients of the variables are going to be the elements of the matrix. 1, 1, 1. Those are the elements of the matrix. You can see that are the numbers in the equations, and then the unknown variables I, j, and c. Just how matrices work, that I would multiply this, the j would multiply this, and the c would multiply this, and it would be equal to this. So you have the whole equation set. Down here on the right are the three numerical values that we have in the equations. What you would say is that this is a matrix A. You can imagine what I've written there is bold, being multiplied by some column vector, and that would be equal to another sort of column vector. You can satisfy your understanding of the form that you have here if you perform these the matrix operation, the multiplication here, and you will see the equations previous. You can apply the inverse to both of these using matrix algebra, and actually it's really important the order. So if we apply the inverse on the left hand side here to this matrix, we have to do the same on the right hand side, and I say the right hand side, but you've got to be careful that it's to the left of what's here. So the order is super important. Then what we get is this equal to the identity matrix. It's just basically ones, and therefore disappears in basic terms. Not technical terms, but in basic terms, as much as we need to know. And what you're left with is this. So it's really cool. Like, it defines B, which is what we wanted to find if we want to solve it. Well, what was B? It was these unknown values like I, J, and C. How do we do it? We need to find the inverse of this matrix, because A inverse has to multiply the C. The C, thankfully, is known. And we know about A fully. It's just about finding the inverse, and thankfully the calculator is pretty straightforward about that. So let's start doing matrix stuff. We'll go to our menu button again, and we want to go across to the section 4 where it says matrices. When you first enter this section, it will first ask you to define a matrix, which means we're going to input the matrix ready for use in calculations. Right, so define straight away. If we go to 1, and it's going to ask us how many rows and columns we want. So if we first of all define A, we're going to need 3 rows and 3 columns. You can see it's just a matter of input. So bear with me while I input. Okay, now that's input. All you have to do is press AC to get back to the matrix area. So it's done now. And that's all very well, but we need to also input column vector C. The way to do that is instead of press options, OPTN, and we're going to define a matrix. Well, naturally we'll use number 2. I'm not in the mood to be silly about it. It's good that they say rows rather than dimensions. Some people might get mixed up, right? So we can definitely see we've got 3 rows and 1 column. Yeah, that matches what we want. We'll put the values in. And now that's input, because we've pressed equals on the last element. And we can go press AC again. And we come out of this. Now, we're trying to multiply the inverse of A with the C vector that we've just input. We're going to options 3 and press the special button for the -1 power, the index, and then we're going to just simply use the multiplication button and add the matrix B that we defined. When we press equals, magic. What do we get? 384. Okay, so that 384 is what we had previously when we were looking at the solving it with the simultaneous equations. That's taking a real life situation, turning it into equations, and then seeing a couple of ways that your calculator can solve systems of linear equations.